Hello, welcome back. This is 5-4. We are talking about integration. In these videos, we are going to specifically talk about acceleration, velocity, and position. And if you are familiar with these topics from previous units, you know that usually it's the other way around. We start with position, then we look at the velocity of a particle, and then the acceleration. Well, we're talking integration. Integration is working backwards from differentiation. So we kind of reverse it. So the problems that we're going to look at, we're going to be given the acceleration, and we're like, okay, well, if I have the acceleration, how do I go to velocity? Well, you need to anti-differentiate or integrate. Okay, so let's go ahead and look at some examples. So note, if we know the acceleration for an object and if we are given the initial conditions for the object's velocity and position, integration allows us to find the velocity and the positions equations for the object. So here in the highlighted section, it says, remember that position to velocity to acceleration, to move among those, you differentiate. Well, to work backwards, we have to integrate. So let's go ahead and look at example 12. They say the acceleration of a particle at time t is given by the function a of t equals 4t minus 3. And then we're given some initial conditions. Velocity of 1 is 6 and position at 2 is 5. So we want the velocity equation. Okay, well, I'm given acceleration, okay, and I want velocity. So to go from acceleration to velocity, we need to integrate. Okay, so v of t, I'm going to go ahead and integrate a of t. Okay, so v of t is equal to the integral of a of t dt. Okay, so I have the integral of 4t minus 3 dt, which is 4t squared divided by 2 minus 3t, okay, plus, and I'll say c, and I'm going to use a c1. You'll see why later I'm using a c1. Okay, so here's my function, okay, and I can clean this up. I can, woo, we're jumping all over the place. Okay, here we go. We can simplify this. So this would give us 2t squared minus 3t plus c1. Okay, so they give us in the problem, v of 1 is equal to 6. V of 1 is equal to 6. So if this is my function v of t over here, right, this is v of t, okay, v of 1, if I go ahead and plug in 1, that would be 2 times 1 squared, that's just 2, minus 3 times 1, that's 3, plus c1, I don't know what that is, okay, and this is equal to 6, right? And that's coming from right here. V of 1 is equal to 6. So I want to find c, okay? So I can go ahead, I can simplify this. So this tells me that negative 1 plus c1 is equal to 6, which means that c1 is equal to 7. That is my constant, okay? So here is my final equation for v of t, my velocity function, 2t squared minus 3t plus 7. Okay, so it's a good old initial value problem. Okay, so part B, I have velocity. Now they want position. So, okay, well, how do I get position? Well, I take the velocity and I have to integrate. I'm going to integrate v of t with respect to t. Okay, so that is the integral of 2t squared minus 3t plus 7 dt, and this one's going to get pretty gnarly, not going to lie. So 2t cubed, I raise the power and then divide by that power, okay, minus 3t squared divided by that value, plus 7t plus a constant, and I'm going to use c2. Okay, so it's a different constant value. Okay, so here is my position formula, or my position equation. And if I want to find whatever C2 is, again, we use our initial value that's given here. So they say S of 2 is equal to 5. Okay, so S of 2. So I'm going to take my function over here, 2/3 Okay, I'm going to plug in 2 cubed. Okay, minus 3/2 times 2 squared plus 7 times 2 plus C2. And I know that all of this is equal to 5. Wait, 5? Yeah, 5. Okay, so let's simplify. This gives us 16/3 minus 6 plus 14 plus C2 is equal to 5. And let's just clean this up a little bit. It's not going to be, well, it's not the hardest problem. It's got a fraction. Yes, I know. Ooh, fractions. This gives us plus 8 plus C2 is equal to 5. We'll subtract 8, give us 16/3 plus C2 is equal to -3. So C2 is equal to -3 minus 16/3, which is -9/3. And you're like, come on, Schwarber. I know. I'm sorry. Not sorry. -25/3 is C2. Okay? So, what is your function? S of t, the position, is equal to, now we get to write this mess again, 2/3 t cubed minus 3/2 t squared plus 7t minus 25 over trace. I don't know how to say over. Okay, let me know in the comment section. All right, so that is it. That is an initial value problem in application, talking about acceleration moving back to velocity, back to position. Okay, so I wanted to talk in general. So example 13 talks in general about this, and it says, given that on Earth, okay, we're not on Mars, the acceleration of an object due to gravity is approximately -32 feet per second squared, okay, and negative indicates we're going downward. They want us to develop the equation for velocity, and they say v sub o is the initial velocity. Okay, well, I know that velocity is the integral of acceleration, and that is -32 feet per second squared. Okay, and we are talking in relation to t, so dt. Okay, so this is going to be equal to -32, right? That's just a constant. T plus c. Okay, and this is going to be feet per second. Okay, well, v sub o is your initial velocity, right? So that means at time t equals 0, right? V sub 0 is equal to v sub o. Okay, so if I want to solve for t, again, I can go over here. So v sub 0 is equal to -32 times 0. So that's going to go away, plus c. And I know that this is equal to v sub o. Okay, so what we get, right, is 0 plus c is equal to v sub 0, which just tells us that our constant is v sub o. I know it's kind of like really? Like I had to do all that? Yeah, I know, it's annoying. Okay, so here's your velocity equation. -32t plus v sub 0, plus the initial velocity. Okay, so there is your velocity. Now, for the position, things are going to get a little weird, okay? We're going to go all Inception, moving between different levels here. Okay, so I have velocity. Now they want position. So again, I need to integrate v sub t dt, okay, which is the integral of -32t plus v sub o dt. Okay, so what we get is -32t squared over 2 plus v sub o times t plus c2. Okay, and again, they say S sub O is your initial position. Now, if you've caught on, you can kind of tell that, hey, I'm just going to tack on the initial position to this, and that's correct. But what I want to do is model this, right? So again, your initial position, this is when t is equal to 0, right? They say that S of 0 is equal to your initial position, which is like a duh. So we'll go ahead and do this. So S sub 0 is equal to negative 32 t squared over 2. I know I could clean that up, but there's really like no point. Oh wait, I forgot. T is 0, okay, times 0 squared plus v sub o times 0. So all of this really, what's happening? It's disappearing, okay? And we end up with this, that C2 is equal to your initial position. Duh. Okay, so here is S of t, okay? And I'm going to clean up, right? Negative 32 divided by 2 is negative 16 t squared plus my initial velocity times t plus the initial position. There is S sub O. All right. Okay, so that is it for these applications of integration. Whew. Hope you're ready for this. Integration is the fun. It's the best. Catch you next time. Peace.